Concepty problem number 4. It's got this figure. It says a particle of mass m that's not shown in the drawing is to be moved from an infinite distance to one of the 3 possible locations. So let's give ourselves a little drawing here so we know what's going on. So we've got this number line. There's a particle here of mass 2m, a particle of mass over here, mass m, and then the following 3 points are labeled A, B, and C, such that all of these distances are the same. So this is a distance of D, this is a distance of D, this is a distance of D, and this is a distance of D. Yes? Okay? So what we're going to do is we're going to take this third particle, which, does it give it a name? Nope. It's just third particle. Here, I'm going to call it particle 3. There we go. Done. All right, so what we're going to do is we're going to take this thing and move it from infinity to one of those 3 places. And we want to rank them according to the work done by the net gravitational force on moving the particle greatest first. So I guess what we should be thinking about here is when we talk about work, we should be thinking about change in energy, right? All right, so if this thing is literally out at infinity, that's as far as I can go, but if it's out at infinity, what would the gravitational potential energy be there? 0, right? Do you guys get that? So the whole premise behind the 14.2 stuff is that we've kind of flipped around our perspective on gravitational potential energy, right? It used to be that as you moved an object up, you gained gravitational potential energy, right? Which is still true. All right. The only difference is we used to describe it as going from some positive number to some bigger positive number, right? And now what we're saying is gravitational potential energy is always negative, and the farther your objects get away, the more it increases. In other words, the closer it gets to 0. Follow? All right. So the idea is my initial gravitational potential energy, I'm using U for potential energy. Is everybody cool with that? All right, so that's 0. So what I want to do is I want to figure out, well, so let's do this. So the question wants to know how much work is done by gravity, right? So is that equal to the change in potential energy? Is that a correct statement there, you guys?
Is it opposite?
Good, it's opposite. Right? Remember that? All right, so what I want to do is find my change in potential energy, and then I just need to be careful about these signs. Okay? So regardless, I'm going to start with an initial gravitational potential energy of 0. So let's do this. Let's rank the gravitational potential energy at A, B, and C. Which of those 3 do you guys think would be the biggest, and why? Sure, what do you got, Adam?
B, because you have both 2m and m.
Okay. Well, that's true in all 3 cases. I mean, even over here at point A, there's still gravitational potential energy from the 2m and the m.
But like you're close.
There you go. Good. So that minimizes the distance for both masses, right? Does that make sense? So this one is going to be the biggest, right? Now, when I say biggest, what do I mean? Do I mean the most negative or the least negative? These negative signs this chapter always mess me up. I need to think about it. Let's see. So we've got, I know these negative signs always mess me up. I hate this section because of these negative signs. I always have a tough time with it. Let's see. So, oops, that's not what I wanted to do. So potential energy is G M1 M2 over D, right? So these are going to, oh, but negative, right? So these are going to have small d's, which means a big negative U, right? So I think this is the biggest negative. Let me pause there for a minute. Does that make sense? Do you guys see why it's the biggest negative? So it's technically the least, right? Does that make sense? What's wrong?
You said all these guys have small d's, and I started my.
Oh, I gotcha. Okay. All right. All right. Is everybody good? All right. Now, so what's going to be the next biggest negative? What do you guys got? I think A is our next best, right? Because these two are similar. The only difference is this one is closer to a bigger mass, resulting in more negative potential energy, right? So this one is the mediumest negative. Mediumest is not a word. All right, and then this one is the smallest negative, right? Cool? So when I find my delta U, I'm going to take a negative number, right? Because you want final minus initial, right? So I'm going to take delta U would be, in this case, it would be a big negative minus 0. So the work done by gravity is actually going to be the biggest positive, right? Does that make sense or no? All right, so this corresponds to the largest work by gravity. So biggest work done by gravity, which then means that this one must be the smallest work by gravity. Follow you guys? Those are a drag, so you really got to be careful with those signs. Any problems with it? Everybody's happy? Is anybody lying about their state of happiness? Yes, talk to me.
Just clarification. The change, so for B being the biggest negative, that's the biggest negative change in potential energy. But
Correct.
The biggest positive work.
Exactly, that's exactly correct. Good?
Yeah.
I know, it's confusing. All right, so everybody's happy, yes? Awesome.